Okay, now they ask us to prove that two triangles are similar. Now I've colored them out, R, K, M. So go from R all the way to K and then to M and put a color around it. I'm looking at that red triangle. That's good to see. And then prove that it's similar to triangle ROT. ROT. You have to know that similar means the angles match up. The angles must be exactly the same. They might be a different size, but the angles will match up. Well, let's try it. And you start off, you say in triangle RKM and triangle ROT, KRM and RTRO. This angle R is common. You could just say angle R is common. So there you've got one of the angles. That wasn't so hard. Now look, do you see something? Well, look at this X here and this X here. It looks like angle K1. Angle K1 is equal to angle O2. They're both equal to X. We've just matched up two angles, the common angle and K1 with O2 in this red and blue triangle. So they both equal X. Well, now that we've matched up two angles, we can say that the two triangles, RKM and ROT, are similar. Maybe I should just say they are similar. They are similar. Maybe I'll write that. I would write that they're similar. Therefore, I'd put the similar symbol in between there. But right for now, just to say, you've got to say it. Those triangles are similar. We can say they're similar now. That's the whole point. Are similar. And you could use these symbols. You could write that down instead of that and there. Okay, let's go on to the next one right there, which is, it's a little bit scary because they ask you to figure out this distance MR. But what they do is they tell you KR is 8. So what you do is go, okay, KR. And then I wrote just an 8 on there. 8 centimeters all the way from K to R. You just put it on. It's this blue line here. And they tell you that KO is 6. So I put 6 centimeters here and a blue thing there. And then I connected the two because, it's very likely we're going to be dealing with this triangle. And that's how easy it is. Gee, 6 and 8. If this was a right angle, I could use Pythagoras. But hey, it is a right angle because this tangent is perpendicular to the radius. So 6 squared plus 8 squared equals OR squared. Well, that's 100. Square root it. I just figured out the distance OR, which is 10 centimeters. Now, this is a radius, so KO is 6 centimeters. OM is 6 centimeters. So that means that MR must be 10 minus 6, or 4 centimeters. And that's all there is to it. That's finding MR. Now, say we want to find KT. Well, it's likely if we were asked to prove similarity that we're going to use similarity. And the way similarity works is I can make proportional fractions, all sorts of them. I can go RK goes with RO. I could go KM goes with OT. Or I can go RM goes with OT. The thing is, I've got KR and I've got RO. I know it's 8 over 10. And RT is going to help me get at this KT part. So I probably should use RT. Well, I know that RM, which we figured out is 4, it goes with RT. Well, I just solved this. I multiply by RT up here. 10 times 4 divided by 8. RT is 5 centimeters. That's 5 centimeters. Then this KT must be 3 centimeters, because 8 minus the 5 equals 3 centimeters. And there you go. We just did that question that looked really hard. But if you just calm down and put a line on where they say KR is, put a line on KO, you're looking at the triangle that you have to figure out. And there you go.